Alright, this video is to show you a way to help chemistry students write chemical formulas of ionic compounds when they only have the words. So, let's say that you gave a student lithium chloride. Alright, so lithium chloride. How are you going to write the formula of lithium chloride? Well, normally, most teachers introduce the different columns of the periodic table as being associated with ions of a different charge. So like lithium has the symbol Li. Since it's in the first column of the periodic table, it is going to lose one electron and ionize to become a +1 ion. Chlorine is in group 17 or 7b, and it's going to ionize to give you a -1 ion. The idea of forming an ionic compound is that the charges have to add up to 0. So the positive and the negative cancel out, you get a neutral ionic compound. I know an actual ionic compound structure is more than that, but this is how most teachers kind of teach this thing. It's hard for students to actually see this sometimes though. Some of them don't get the math. They can't do it in their head, and they have trouble writing it out if you try to teach them to write it out with a formula. So what I've done is I've created these. For every positive ion, I have a circle with a hole in it. As you can see here, this hole represents the positive charge. The lithium ion has given up an electron. For every negative ion, I've got dots. So this chloride ion here has one black dot. The idea is the students can figure out the symbol for each one, take them, and match up one dot for each individual hole like this. So you line them up like this. So the hole in the lithium covers the dot on the chlorine, and there you go. This represents your structure. You've got one Li and one Cl. The idea then is that the student can write the formula LiCl, and there you go, there's lithium chloride. You can do this with more complex ions as well. Let's say that you wanted to do magnesium oxide. Okay, so again, like before, using the periodic table, they ought to be able to determine that magnesium has a +2 charge and the oxide ion has a -2 charge. So what we have here then instead is 2 holes for magnesium and 2 dots for oxygen. Again, just like with the lithium chloride, put the holes over each dot, and there you go, they match up. Here the student can see, okay, I only need 1 magnesium for each oxygen, so the formula is MgO. And likewise, you can do this with a compound where you have a +3 and a -3, like aluminum nitride. Again, match them up. But what if you have a situation where the numbers don't match up right away? I've tried to format these so that that'll work out just fine. Let's take aluminum oxide as an example. So, aluminum, we anticipate a +3 ion because the electron configuration ends in 3p1, so it's going to be more likely to ionize by giving up 3 electrons instead of gaining. Oxygen we talked about already, -2 ion there. I try to ask my students, what number do 2 and 3 both go into? Because when you form an ionic compound out of these, you got to get the charges to balance. Well, most of them tend to get that we need 2 aluminums and 3 oxygens, because you want the total positive charge to be +6 and the total negative charge to be -6 so that they cancel out. They may not be able to see this. For those who can't see this, I would want them to not just start with one aluminum and one oxygen, because here they can try it and they can see, okay, well, I don't have enough dots to cover in all the holes. So they can then try and add an extra oxygen. And if they try and add an extra oxygen, what's going to happen? Well, if you add an extra oxygen, now you have all of the holes filled in, but you don't have all of the dots filling in a hole. So now you can just grab an extra aluminum and cover up these dots, and then finally use one more oxide ion to fill in so that everything matches up. For every hole, there's a dot. For every dot, there's a hole. Once they get everything matched up, they can count them and say, okay, there are 2 aluminums and there are 3 oxygens. And that should lead them to the same conclusion for the formula right here. I've prepared these in sheets that can be cut out. They show up like this. If you're getting this from me on TPT, you're going to get a bunch of sheets like this. I've put down a bunch of commonly used elements that ionize along with some polyatomic ions. You buy this thing from me, you're going to get a bunch of these in sheets like this. And also, you're going to get blanks so that if for whatever reason you don't like my layout or the ones I've given you become destroyed, okay, well, you've got blanks that you could just print out, cut out, and fill in. The size of these holes are equal to the size of a typical hole punch that most teachers have in their classroom. So print them out, punch the hole, you're ready to go. You can help students out with this who are struggling. Maybe they can't see it in their head, maybe they need the visual aid. Give it a try. You may find that it makes your life and their lives a lot easier. Thank you for watching.